Here we go. Arc length coming at you. All right, what are we doing? We have a curve corresponding to a function. And we would like to find the arc length from A to B. So what I mean is you take, this part of the curve here. You imagine it's a piece of string. You pull it straight, and then you measure it. And we would like to find that measurement. So how are we going to do this? Well, we're going to construct an integral, which means we are going to start by subdividing our interval. So I'm going to take 4 subdivisions, 1, 2, 3, 4, and see what happens. So let's find the corresponding points on the curve. There's 1, there's 2, there's 3, there's 4, and there's 5. So we're going to start with an approximation of arc length. So we're going to connect these dots with straight lines. Let's get my straight line tool here. All right. So connect these dots with straight lines. Okay. Now, it'd be fairly easy to add up the lengths of these straight lines. So let's try to do that. Now, where is my tool? There it is. So let's start by looking at this line segment here. What do we get? Well, the length of that is given by Pythagoras, right? So we will use some shorthand here. We'll call this length here delta x. And we'll call the vertical length here delta y. So the length of this line segment is given by Pythagoras. We get delta x squared plus delta y squared. And then you got your square root from Pythagoras. Okay. So we're going to simplify this a bit further. We're actually going to factor out delta x squared. What do you get? You get 1 plus delta y over delta x squared. Oops, still in the square root. And then we have our delta x squared that we factored out, like so. And what does that give us? Well, we get the square root 1 plus delta y over delta x squared, and then just a delta x here. Okay, now what? Well, what you would do is you would add up the four pieces here. So let's say arc length is approximately equal to summation I equals 1 to, well, we'll put an n here. In this case that I've drawn here, we have n equals 4, but we're going to add up 4 pieces, and each time we'll be adding this funny looking expression here, taber what? Et voila. So that's an approximation. Now we'll do what we did when we introduced the Riemann integral, is we will take a limit of this expression as n goes to infinity. Okay, hopefully that makes sense to you. Okay, instead of 4 intervals down here, you take 8, then you take 16, then you take 16 to the power of 16, and what you're going to get is a better and a better approximation for the arc length. And if your function is well behaved, you will get arc length is equal to the limit as n goes to infinity of this sum. It's a funny looking sigma. Too much coffee this morning. Okay, this delta x on the end is most certainly outside of the square root. Okay, calculus fans out there will remember that this is exactly a integral. Limit of a sum in this way. And which integral is it? Oh, excuse me. 1 plus, okay, very roughly, the deltas become d's, and delta y over delta x becomes the familiar derivative. Okay, so this is the formula that you should memorize. Arc length is this guy.